Can you hear me?
Yes, ma'am, we can hear you.
Okay, if
Yes,
something
ma'am.
goes wrong, just tell me. Yeah? Okay. So now there are 39 people. Now there are 40 people. A while back, when I started speaking this statement, there was 39. Now one more person has entered. So because of shaky internet, some of us will get thrown out and some of us will come in. Now suppose that when I started speaking, there are 39 people in this room. And let us imagine that every minute, either 5 people are thrown out or 10 people come back into it. Is it possible that at some point in the next hour, we are looking at we are looking at it minute by minute, okay? So right now we are here, there are 39 people. Now at the end of 1 minute, either 5 people will be thrown out or 10 people will be coming in. Another minute, either 5 people will go out or 10 people come in. These are the only two things that can happen. And we have this 1 hour slot with us. Yes, who was that?
It's me, Saranya, ma'am.
Yes, Sharanya, what do you have to say?
But in the question, it says that 5 people either enter or 10 people are thrown out, ma'am.
Okay, sorry. So either 5 people enter, thank you for that. Either 5 people enter the room or 10 people are, either 5 people enter or 10 people are thrown out. Is it possible that at some point in the next hour, there will be exactly 100 people in this room? You got the question, right? Take 2 minutes to think. I'll wait for 2 minutes and then I'll start calling out people. If question is not clear to anyone, you can ask.
Ma'am, is it 39 by n?
I don't want to know the answer right now. What did you ask?
Is it 39 by n people in the room?
No, there are 39 people in the room. When I started speaking, there was 39. And every minute, either 5 people enter the room or 10 people are thrown out.
Ma'am?
Is it possible that at some point, there is exactly 100 people in the room?
Ma'am?
Yes,
Can I ask something?
yes, ask.
So, is there a pattern that either 5 people will enter at a time and then 10 people will leave, or
No,
is not a pattern?
no, there is no pattern.
So it may be that in 20 minutes 100 people enter, but also maybe that in 20 minutes 200 people leave it.
In 20 minutes, can 100 people enter? Yes, they can, right? First 10 people enter, then 10 people enter, then again 10 people enter. No, we have only 5 people entering. Sorry. 5 people enter, then 5 people enter, 5 people enter. So, yeah, so 100 people can enter or 200 people can leave. Yes, that's right. That is possible.
Ma'am,
Hmm.
ma'am, it is not possible, ma'am.
Who was that? Ishan, is it?
Yes, ma'am.
Okay, wait, Ishan. Let me call out. There are a few other hands which are raised. Atharv, I can see your hand raised. Atharv, do you have to say anything?
No, ma'am, my hand was raised by mistake. Sorry.
Okay. Adrit?
Ma'am, it's not possible.
Ma'am, we cannot have exactly 100 people in the room after 1 hour.
No, I have called out someone. Can I listen to them, please? I have called Adrit.
Ma'am, we cannot have exactly 100 people in the room after 1 hour because either 5 people enter the room, ma'am. So when they enter, it can be, the unit digit can become 4, or if it's already 4, it can become 9. And if 10 people exit also, it can be same 9 or 4, ma'am. But for in 100, we have 0 as the unit space. So we cannot get exactly 100 people in the room after 1 hour, ma'am.
So you're saying that units digit cannot be anything other than
4 or 9.
4 or 9. Okay. Somebody else was speaking. Who was that? Who was that when I gave Adrit chance to speak? I said no to someone. Who was that? Can that somebody come forward and speak now? Advait, if you're speaking, you're muted.
Ma'am, can I speak, ma'am?
Who's that? Yes, go ahead. Go ahead.
Ma'am, actually, ma'am,
Hmm.
100 is a multiple of 5 and 10, both of which are the numbers that need to be added or subtracted. However, 39 is not a multiple of 5 or 10. Thus, no matter how much time it takes, the room would never be filled with 100 people.
Okay.
Ma'am, can you just scroll up so that I can read the question again? Thank you, ma'am.
Does anybody else have to add anything?
Ma'am, me.
Who's that? Huh?
Others.
Yes, go ahead. Go ahead.
So as another student was saying, my answer was the same, because if we 39 is not divisible by 5, like 5 or 10, but 100 is. So it is not possible that if we minus, like if we plus 5 or subtract 10, the answer will be at the point.
Okay, can I hear one more voice? I know that there are 12 hands raised. So one person. Can I ask Harish? Harish, can you call out somebody?
Yes, ma'am.
Huh.
Athar, you had your hand up.
Atharv, I think, spoke.
Okay.
Arav.
Rishit, you have it.
Okay, go ahead.
Ma'am, I want to tell the same thing, that the ones place digit will always be 4 or 9, so we cannot get 100.
Okay, can somebody tell me what is the invariant here? We were talking about invariant.
Ma'am, can
Okay.
I tell?
Yes, go ahead.
Ma'am, so 5 and 10 is a multiple of 5, and so if you add any multiple of 5 to another multiple of 5, you will always get a multiple of 5. But then if you add some other number, say 39 in this case, to a multiple of 5, you will never be getting a multiple of 5. So 100 is a multiple of 5, and you will adding a multiple of 5 to 39. So negative numbers are also multiples of 5. That's what you get by subtracting 10. So you will never be getting a multiple of 5 if you add another multiple of 5 to something that's not a multiple of 5.
Okay, so let me sum up what you had said. 39 is not a multiple of 5, is not a multiple of 5, okay? And to 39, you are adding 5 or 10. 39 plus some number of 5s and minus some number of 10s is never going to give you a multiple of 5, is what you're saying, right? So let me say that what is the remainder when 39 is divided by 5?
4.
4, right? 39 gives a remainder 4 when divided by 5. Now, yes. So now if I add 5 people or take away 10, both of it being multiples of 5, it is not going to affect the remainder that the number of people in the room will give when divided by 5. Like you said, the units digit will be either 4 or 9. Of the number of people in the room, the units digit will be either 4 or 9. Whichever way, the remainder when the number of people in the room, remainder when number of people in the room is divided by 5 will always be what? 4. So this 4 remains invariant when we add 5 or subtract 10. Is that clear? Where invariant comes from? What the invariant is here?
Mom, the invariant is the remainder that the number of people leaves.
Invariant is the remainder when the number of people in the room is divided by 5.
Yeah.
Okay, that remains the same. So oftentimes looking for what remains the same when something else changes will be a good problem solving strategy. Okay, I gave you a simple problem. Now let's look at this. Can you read the question? There are 3 piles of candy. The first one has 2 candies.
2 candies.
And the second one has, why is it not writing?
3 candies.
Okay. So the first one has 2 candies, the second one has 3 candies, and the third one has 4 candies. Now what will you do? You can choose any 2 of this. Say I choose this and this, and I will add 1 here and 1 here. Like that you can go on adding, choose 2, add 1 both, and can you get 200, 300, 400 candies at any time? I can see Ishan's hand up. Now are these all people who have got the solution? Harish, you need to help me with this. Call out people who have not spoken. Call out people who have not spoken and yet their hands are raised.
Okay, ma'am. Ashwath?
Yes.
You had your hand raised?
Yes.
Think about the question.
Okay, how about Advait?
Ma'am, actually, ma'am, we can obtain the 3 piles that we can obtain 3 piles that contain 200, 300, and 400 pieces of candy. If we suppose that the pile 2 is pile A, the one with 3 candies is pile B, while the one with 4 candies is pile I'm sorry.
C.
Ma'am, actually we cannot obtain that, ma'am.
Okay. Why is that?
Ma'am, because instead of adding 2 to each, ma'am, instead of adding 1 to each, ma'am, we're adding 396 to 400, 200 to 300, and 198 to 200 to make it 200, ma'am. So since
You're
it's
saying
exponential rate, not an exponential, ma'am, it's too high to be filled with just 1 candy at a time, ma'am.
okay. You can go on doing it forever. I think I heard you're saying that we are adding unequal number of candies to each pile. That is one way of looking at it.
Yes,
Ma'am,
ma'am.
I said my answer on the chat.
I don't see the chat. Can you read out, Harish? You can speak out. You can speak out, whoever it is who
Ma'am,
send
it
the
was
answer.
the answer. It will not be possible because if we choose 2 piles at a time and then another 2 the next time, one is going to be repeated and thus creating an imbalance.
You can choose the other 2, no? First I can choose A and B. Okay. Then I will choose B and C. Then I will choose C and A. So that imbalance which you are talking out will be taken care of at the end of 3 turns. Now all 3 piles get 3 candies each. Yes, Shraddha, let's hear Shraddha and then whoever it was that said. Shraddha, what do you think?
Ma'am, so we have 2, 3, 4, and and 4 pieces, and then we have at the end we have 200, 300 and 400 pieces. So like can the pile with 4 pieces at first become 200 pieces?
Yeah, it can. It can.
So there's no there's no compulsion to become
No,
400
no.
only.
No.
So then
Huh.
we are repeating this operation a number of times to each pile. Then we add 2 candies every time we do. So my suggestion is that we check if it is divisible by 2. And then we can proceed.
Okay, so let us check if it is divisible by 2.
But
We have
but it is actually it is not divisible by 2.
Okay, what is not divisible by 2?
So like if you 200, 300 and 400 are all even numbers, and then 2 and 4 are even numbers. Okay, so if you subtract 2 and 4 from one of the numbers each, then you will end up with another 2 even numbers, and they will both add up to be even. Then we have 3, and you're subtracting it from an even number, you'll of course be getting an odd number.
Shraddha, you are very close but not quite there, because on the 3 pile I can add 1 candy, no?
I don't get it.
You don't get it. Okay, so what you're saying is that even number 2 can become 200, 4 can become 400 or 200, whatever. But you're saying that the 3 cannot become 300 because we are adding 2 candies at a time. But to each pile, we are adding only 1 candy. No, we are not adding 2 candies. Sandhya, I see your hand up.
But
Yes.
totally we are adding an even number of candies.
So?
In total, we are adding an even number of candies, so it is not possible.
Say that again. Shraddha, say that again.
So, in total, how many candies are you adding to all the piles together? That must be an even number, right?
That must be an even number.
Even number plus odd number is odd number.
I got it. Yes. Now somebody else wanted to speak. Sandhya, yes. So that's not Sandhya. Maybe you.
Ma'am, it is not possible to reach 200, 300, 400 from 2, 3 and 4 because the total candies parity never matches, ma'am. The total always stays odd, ma'am. Like 9, 11, 13, it goes like that, but 900 is even, ma'am.
Okay. Ishan, do you have to say anything? Ishan?
Ma'am, if we had 100, like 1 plus 1 plus 1 to each in 100 times, ma'am, it will become 200, 300, 400, ma'am.
No, but you are adding only 2 at a time. So what 2 of you said? Reyansh, do you want to say something?
Ma'am, because the LCM of 2, 3 and 4 is 12, 200 and 400 are not divisible by 12.
That doesn't tell me why you will not reach. It's like what Shraddha and Sandhya, probably you need to rename yourself. What they say is that totally we have 2 plus 3 plus 4, which is 9 candies. And irrespective of which pile we add to, we are adding 2 candies at each step. So total candies will be like to 9 is an odd number. To 9 you are adding 2 plus 2 plus 2 plus 2 like that. So always the total number of candies in the 3 piles, number of candies in the 3 piles has to be what? Odd. Because you're starting with a odd number and you're keeping on adding 2 at each step. So if it were possible for you to end with 200 plus 300 plus 400, this sum would be what? 5 plus 4, 900, which is an even number. It can never reach an even number, which is what Shraddha and Sandhya said. What's your name? Whoever you have named.
I changed my name.
You change your name. You change your name. It's still seen as Sandhya for me. Okay. So this is what they both said. Is that clear to everyone? If it's not clear to anyone, please. Adrit, yes. Is it clear to you?
I have a different way to solving this.
Yes, yes, go ahead.
So, ma'am, let's say we are adding 2 to each pile, right? So we'll
Not 2 to each pile. Not 2 to each pile. We are
1 to each pile.
1 to 2 of the piles. Yes.
Yeah. So if we mix all these piles up, then we're adding 1 to each of these piles. So total it's 2 we're adding candy every time, right? So if we mix up all these piles, there'll be 9. So, I mean, if you mix up 200, 300, 400, how much is it? 900.
900.
From 9, by adding 2, can you get to 900? No, you
That's
can't.
exactly
The
what.
closest you can get is to 899.
That's exactly what Shraddha and Gagan said.
Oh.
Yeah. Okay. Is that clear to everyone?
Yes, ma'am.
So shall we move on to the next problem?
Sure.
Ma'am.
Yes, Shraddha.
Ma'am, that's not exactly what I thought, but totally you are adding an even number of candies, but you will in this case you will never be adding an even number of candies if you want to reach this results.
No,
So
you start with an odd number. You start with an odd number, and to reach an even number, you need to add an odd number of candy, right? If you have to reach a total of 900, starting from 9, you need to add how many? 891. 891 is odd. You cannot add 891 by adding 2 plus 2 plus 2 plus etc. Yeah, that's right. Okay, so let's move on to the next problem. I don't want to do this. Let's do this. Okay. I write numbers 1 to etc. up to 10 on a blackboard, right? Like I do this. 1. Why is it not writing? Okay, you read the question. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. I have 10 numbers written on the board. Now, what do? I take out 2 numbers, say 4 and 7. And instead of 4 and 7, I write 11 there. Okay? I write 11 there. Now, like I choose 2 other numbers. Which number should I choose?
Ma'am, 10 and 11.
10 and 11. Okay. So I will erase 10 and 11. And what should I write?
21.
21,
ma'am.
Okay.
Ma'am, can I can you scroll up?
Ma'am, can I solve this, ma'am, Abhinav?
Wait. I will write.
Ma'am, can I solve this, Sadhra?
Wait. Let me write 10 and 11. If I remove, I will write 21 here, right? I'll write 21. And now one more step.
21
and 6.
2 and 3.
5 and 6 I will remove.
21 and 1.
Ma'am, can we take 2 and 3?
Wait. You can take any. Now, if I take 5 and 6, what will I do? Instead, I will write 11 there. 11, right? I can go on doing this. Now, if I take 2 and 3, I will write 5 there instead. And what will happen at last?
Ma'am, I see that in these 10 numbers, the sum of every 2 consecutive numbers is an odd sum.
No, now what will happen if I go on doing this? If I go on doing this, what will happen in the end?
So
ma'am, can I say?
Ma'am, it will come to 55 because 1 to 10 when all added together comes as 55, which is odd.
In whichever number, in whichever order I add?
Yes, ma'am. Yes, ma'am. Whichever order we take, we'll only get the sum of the given 10 numbers. That means that it should be the sum of the 10 numbers, which is 55.
55. So you say that eventually I will have one number left and that one number will be odd.
So ma'am, you don't need to add it like number by number, like 2 number by 2 number. You can add all the numbers at once and you'll get the same answer.
Ma'am,
You'll
I
be getting
see.
only one answer, the same answer.
Ma'am, the answer will be odd.
The
Guys,
answer will be
please,
odd. No,
guys,
let
please
them
raise your
talk.
hands if you want to talk.
Ma'am, can I say?
Yes, who is that? Can I say? Whoever it is,
Ma'am,
go ahead.
ma'am.
Mayan, go ahead.
Ma'am, each time we add any two consecutive or any two numbers, at last we will sum all the numbers only, because we will get the sum of all the numbers at last, because we are adding the same numbers only. That's why the sum of all 10 numbers will be 55 and the answer will be 10 odd number.
Okay, okay. So this one, what remains invariant and what changes here?
Ma'am, can I tell?
Yes.
So, ma'am,
There is a lot of
remains
echo.
invariant.
Can I say, ma'am?
Ma'am,
Can I?
55 remains invariant.
The sum remains invariant. And
The
what
way
is
you
variant?
add them
Can I tell how to do?
can change. The way you
One
add
at a time, one at a time, please, one at a time. Harish?
Guys, please do not talk over each other. One at a time,
Yeah.
please.
One at a time. Let them all, like whoever has got the hand raised, let them speak this thing. Now one rule is that like whoever has spoken should say something new. There is a question. Yeah, I heard that the sum will always be 55, right? So which means will it be even or odd? The answer to my question is odd, and 55 is that odd number. And you're also saying that the sum is the invariant. Sum is the invariant. Okay. Now tell me what varies here. I said you need to look for an invariant amongst something that varies. What varies? Harish, please call out in the order.
Yes,
in
ma'am.
my list, Abhinav is the top in my list.
Yes, ma'am. I have the same order.
Okay, go ahead and call.
Okay, ma'am. So here the sum is the invariant, and the variant is that the numbers which you are choosing to add up for the final sum, which is for example 1, 2, 3, 4, 5, 6 till 10. We may take 9 and 6 or 5 and 3. It may vary. So that's the variant here.
So can I say that the order in which I choose the numbers to add,
Yes, ma'am. That is the variant, basically.
Is the variant. So now, like we are looking at what is the invariant amongst something that varies. Now, whatever way I vary, what remains invariant? The sum remains invariant.
Yes, ma'am.
Now I want to go back to the previous problem. Here, what is the variant and what is the invariant?
The variant is the way in which we give plus 1 and plus 2 to each of the piles, and the last final answer which we get is the invariant, I think.
I have a slight disagreement. Now, Aniv is the next one. Harish, I think you call out.
Yes, ma'am. Aniv, I hope I'm pronouncing your name right.
Yes, sir. So the sum of the numbers from 1 to 10, if we even add up two
it's
at a
for
time.
this question. I've changed the question now. We went back to the pile of candies question. In the pile of candies question, I am asking what remains the same. The variant Abhinav pointed out is the order, like which two piles we might choose to add. Like first I might add to AB, then I might add to B and C, then I might add to C and A, then I might add to A and B, then again A and B, then again A and C, like that. This varies. The two piles that I choose to add two candies to varies. But irrespective of the piles that I choose, what is it that remains invariant throughout?
The thing that remains invariant is the fact that the total of all the candies is always going to be odd.
Yeah. So we call that as parity. Have you heard the word parity? Yes. Parity is whether it is odd or even. So here what remains invariant is, let me put it as the oddness of the total number of candies. For want of a better word, I will write that as oddness of the total number of candies. That remains invariant. In a more mathematical way, we will say that the parity remains invariant. Okay, so in all these questions, I asked you whether something is possible or not, right? So we look at what changes and what is it that remains the same. So that what remains the same, is something which will lead us to the answer in many different kind of problems. So I'm going to expose you to a whole lot of such different problems. So here we have a similar this thing to what we did. Like instead of writing 1 to 10, I'm going to write from
Ma'am,
1
I have
to
one
11.
doubt.
Yes. Go
Ma'am,
ahead.
my doubt is that when you said that parity is the invariant, I cannot understand how it is.
Ma'am,
Can
this
somebody
answer
explain?
is.
Can somebody explain why parity is invariant? Why did I say that parity is invariant? Can somebody explain? What is I said parity is the oddness, right? Where is that? Here. Who asked that question? You start with 9.
Ma'am,
Then you start with 9. Then you add 2. Total of 9. I don't care how that 9 is distributed amongst the 3 piles. Then I choose 2 piles and I add 2. So I get 11. Then I choose some 2 other piles and I add 2. 13. Then I choose 2 other piles. I don't care which piles I choose. I get 15, 17. So these are the numbers that I can get at each step. Whichever piles I choose, I'm always going to get an odd number. So the odd number, I am going to get an odd number. So whether it is whether a number is odd or even, that is called as the parity of that number. The parity of that number is going to remain invariant here because it's always going to remain odd. Is that clear to everyone?
Yeah, ma'am.
Okay, so now let's go to this question. Here I wrote 10 numbers and I deleted 2 and I wrote the sum. Now what I'm going to do is I'm going to write 11 numbers on the board. Okay, I'm going to write 11 numbers on the board and I'm going to what am I going to do? I'm going to delete 2 and write the difference. I'll write the positive difference. I will not write the negative numbers. Okay, so let me have, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 and 11. Now what will I do? I will delete 2 of this. Say let me delete 4 and 5. Sorry, 4 and 3 and the difference is going to be 1, right? So instead of 4 and 3, I will write 1 there. Now what will I do? Now what will I do?
We can take any other 2 numbers and then replace them by the positive difference. Like if we take 7 and 9, it is 2. 9 minus 7 is 2.
9 minus 7 is 2. So this is how I am going to do it. Okay. So now you know that there are many different ways in which I can do. So many different ways in which I can do, right? I can first take 10 and 9. I can take 10 and 1. At the end, what will happen? At every step,
Ma'am,
at
could you
every,
show the question one time?
Can you see the question?
No, ma'am.
No? No?
Yes, ma'am. Thank you, ma'am.
So at each step, I'm going to strike out 2 numbers and add 1 number, right? Each step, I'm going to strike out 2 numbers and add 1 number. So what happens to the total number of numbers there? I started with 11. Then I will strike 2 and add 1. So how many will I have?
Can you say it again, ma'am?
I start with 11 numbers. So at each step, I'll strike out 2 and add their difference, right? So if I start with 11, after one game, after one turn of the game, how many numbers will I have left?
10.
10 left.
10. Then the next step?
9.
9.
Then
8.
7, 6, 5. At last, I will end with 1 number. Now I am asking that 1 number whether it will be even or odd.
Ma'am, can I answer, ma'am?
Ma'am, it's
Yes.
even.
Ma'am, it's even.
Ma'am, it's even. Ma'am, it is odd.
Answer,
It is even.
Ma'am, it is
No,
even.
it doesn't.
It is odd.
Even.
I hear that there are a few of you who are saying that it is even,
It's
and there
odd.
are a few who are saying that it is odd. In the earlier case, you were very clear that the number is going to be 55. I could also see that the number is going to be 55. In this case, those who are saying even, what is that number going to be? Those who are saying odd, what is that number going to be?
The number is going to
Ma'am, my number is
Ma'am,
1.
the even number will be 6. Ma'am, the even number will be 6.
Ma'am, even number
Why?
will be 0.
Even number will be
Ma'am, my number is
Okay,
0.
guys.
Okay, guys, everyone stop talking, okay? One by one, state what you want to say. Okay, so can Gagan Karthik first start?
No, Gagan, Karthik, I want to wait. Gagan, I will wait. I'll come back to you the last. Let's take the other hands.
Sure, ma'am.
Okay, Sri
uh,
Yagnika, do you like to go ahead?
Go ahead. Harish, what was the name you called?
Yes, ma'am.
Huh.
Ma'am, I say it would be 0. I'm getting an even number.
Okay, you are getting an even number because you played it out, right?
Yes, ma'am.
Now, I might want to play. Now, my question is, in whatever way you play, will you always get 0?
Yes, ma'am.
Then how will you prove that to me? If you just can't say that in whatever way I play, I will get 0. Why would I believe you? Convince me that it will always be 0.
Ma'am, because of parity.
What is parity?
Ma'am, the oddness of a number, like we can say like that.
Okay, why should that make it 0?
Because we can, like, if we subtract any number, we will still get it 0. How many times we will do it?
No, we are going to subtract these two and write 1, these two and write 1, something like that, right? So why will I get 0 always? Is it convincing to everyone that you will get 0? Is there anybody who got a different this thing? I can show you. I can right now play and show.
Ma'am, I
You
got
got
4.
Ma'am,
I got. Ma'am, I got 2. Ma'am, I got 6.
1. Ma'am, I got 1.
You
Ma'am, I
got
got
1.
6.
You got 6. So it seems like we are not going to get one unique number like we got 55 there. So what is happening here? Should we try to play the game once? Let us complete the game once. And let's see what I get, what we get rather. What should I do? You tell me what I should do. I will do that.
Ma'am,
Tell me
shall I
what
call
should I
on
do?
people who have their hands up?
Yes.
Vallabh, you have your hand up.
Tell me what I should do next.
Yes, ma'am.
Tell me what I should do next. Strike out 2 numbers and write the difference.
6 and 5.
6 and 5 I will strike out and I will write 1. Then
You can strike out 10 and 8.
10 and 8 I will write 2. Harish, call out somebody else.
Yes, ma'am. Shreyas, you want to say something?
Shreyas, next step.
We can remove 11 and 2 and replace it by 9.
11 and 2 and write 9 there. Okay. One more.
And then 9 and 2 and 7.
9 and 2 and then write 7. Okay. Now somebody else. Harish, call
Aniv,
out
you want
the
to say something?
We can take is 7 left.
7
What
and
numbers? What numbers? 7 and 2. We get 5.
7 and 2. 7 and 2 and you get 5. Now, what else?
And the numbers left, you can take 5 and 1 and 3. You get 2.
Do we have 3? We don't have 3. We have already taken 3. We have
Okay,
5.
5 and 1.
1.
And you get 4.
Okay. Now, if I take 5 and 1, I will get 4. Then
4 and 1, you get 3.
4 and 1, I will get 3.
And 3 and 1, you get 2.
2. So 2 is one possible this thing. But instead, if I take away 1 and 1, I will get 0. And then 4 and 0, I will get 4. That's also possible. Right? I can get 2, I can get 4. I can get other numbers as well. So here it is very clear that unlike in that case where we always got 55, here we are not always going to get the same number. Now 2 and 4 happen to be even. Can we get an odd number? Will it always be even? How do we approach this? This is the question that I have. Harish, please call out.
Srivatsa.
And we can do different ways. Once again. Now, can I try out and answer?
No, now I don't want to try out. You try out individually and you tell me the answers. If you are getting different answers from 2 and 4, I will write the answer down. Now I don't want to try.
Now we can put then I can't
Can you tell me whether it will be even, odd, or can we say anything at all?
I said it will be even.
You said it will be even, but you didn't convince me that it will be even. You say that it is even. Is it so? In maths, you just can't say that it will be even. Somebody else will say that it is odd. And I will say that I am the teacher and I say that it is odd and therefore it is right. We can't do that. Everybody in this room has to be convinced.
Ma'am, can I
Yes. Yes, Reyansh. Reyansh, go ahead.
Ma'am, can I answer?
Yes, Reyansh. Reyansh, you have anything to say?
Ma'am, it will be odd.
It will be odd. Okay, Reyansh says it will be odd. I don't know. I will put a question mark. Even if I say it has to be a question mark. I think it is even because I got 2 even numbers here. So I will put an even question mark. Somebody has to convince. I think we will call on Gagan to convince us. Yes, Gagan. Gagan, you're muted.
Ma'am, if you see, there are 6 odd numbers now. 1, 3, 5, 7, 9 and 11, ma'am.
Wait, let me write that down. 6 odd numbers. Yes.
Yes, ma'am.
Go ahead.
Number of odd numbers is equals to 6, which is even, ma'am. It remains even till the end.
Why should it remain even till the end?
Because the number of odd numbers is 6, ma'am.
Number of odd numbers is 6.
Yes, ma'am.
But why should the number of odd numbers remain even throughout? And what has that got to do with getting a even number? I don't understand.
Ma'am, but the final answer I got is even, ma'am.
So you think that it has to be even. So I will put +1 there.
Okay.
And there was somebody else. I also think that it has to be even. So we have 3 votes for even and 1 vote for odd. But this is not democracy. We cannot say that whichever gets the maximum votes wins. We have to find out what it is actually. So there are 6 odd numbers and 5 even numbers we start with.
Yes, ma'am.
Now what do we do? Oh, this has to be 9 and this has to be 11. I'm sorry. Now what do we do? At each step, what do we do?
Ma'am, shall I ask someone to answer?
Yes.
Yagnika, you want to answer?
Yes.
Ma'am, we can say that A plus B and A minus B parity is same, as we will get both of them are even.
What is A and what is B and what is this parity? Can you be more specific? Can you explain that a little? I didn't quite understand.
Ma'am, selected numbers. A and
we are selecting two numbers A and B.
Yes.
Now
And
I can select an even number and an odd number. I can select two odd numbers, or I can select two even numbers as well.
Yes, ma'am.
Huh.
But if you like subtract an even and an odd number, you will get an even number. Same with an even and an even number, you will get an even number.
Okay, so even minus even is even.
Yes.
And odd minus odd is what? Odd.
Even.
Am I right? Even. Odd
Even.
minus odd is even.
Yes.
Yes, it is, right? 7 minus 5. Okay, odd minus odd is even. Odd minus even?
Odd.
Odd. Even minus odd?
Sir, odd.
Is also odd. Okay. Now what does this tell us?
Now if you take total sum, you will get even. You will get 66. Actually, you will get 66. Of 1 to 11, you take the total sum, you will get 66.
Sum is 66, but now we are not taking the sum. What we are doing is, we are taking two numbers and writing down the positive difference.
Ma'am, I am removing the sum now.
No, we are not removing the sum. Oh, you are removing the sum.
Yes. And adding.
No, we are not. We are not. Okay, you are removing the sum and adding the difference. Is that it?
Absolute difference.
We are removing the sum. From what? From the total sum.
The total sum, yes. 66.
Okay, if I remove and then I will add the difference. Okay. So at each step, the sum here is 66. So I choose two numbers A and B, and from 66, I will remove A plus B and add A minus B.
Yes.
Or whichever, I will add the positive value of A minus B. Okay. This is what we are doing to the sum. Now what happens to that? So what do we end with if we are going like this?
Ma'am, A plus B is even and A minus B is also even.
If A plus B is even, A minus B is also even.
Yes.
Is that so? When is A plus B even? If A and B are even, if A, let me write this. Okay.
Yeah.
Here we have A and here we have B. A is odd and A could be odd or even, and B could be odd or even. Okay, now I will write, if A is odd and B is odd, A plus B is what? A plus B is, I will first write A is odd and B is odd, A plus B is even. A is even and B is odd, A plus B is odd. A is odd and B is even, A plus B is odd. A is even, B is even, A plus B is even. Now I have written what A plus B is in black. Now I will write what A minus B will be. A is odd and B is odd. A minus B will be even. One is even and one is odd means the difference will be odd. Here it will be, I need to pull it a little bit. Here it will be odd and even, difference will be odd, and even difference will be even. Okay. So if A plus B and A minus B will always have the same parity.
Yes.
Is that clear to everyone? Is that clear to everyone? What I wrote in black and red? If A is odd and B is odd, A plus B is odd. If A is odd and B is odd, A minus B, A is odd and B is odd, A plus B is even, A minus B is even. A minus B I have written in red. Okay, A is odd and B is even, then sum is odd. So this is what it is. When I say it out in words, I'm like too many words are confusing. Basically, a plus b and a minus b will have the same sign, irrespective of what. Okay, now what?
Ma'am, now from 66 you are removing that.
So
even 66 minus even, we will get even only.
But there is 66 minus odd also, no? There is a case, this also is there, and this also is there.
Odd minus odd is even.
How is odd minus odd even?
Yeah, 5 and 3 is even.
No, I'm asking, you have... Okay, so let me write it here. You said 66 minus sum plus difference, right?
Ma'am, a plus b minus mod of a minus b is always even.
So this, let me write this as minus of sum minus difference.
I'm sorry to interrupt. Just a quick reminder, we have 10 minutes left.
Okay, yeah. So you say that because these two are of the same parity, sum and difference have the same parity, you say that what remains will be even. Is that clear to everyone? Is that clear to everyone? Shraddha, it's not clear. Is that what you're saying, Shraddha? Okay, let me try to explain. Who was that who explained?
Ma'am, I wanted to say 66 minus sum plus difference is not needed because it's just like another route taken, because we can also do the problem by a shorter way, knowing that a plus b and a minus b have the same parity. Then you can say all the numbers, you can add them up, you get 66. So they will have the same parity.
So we are not adding up here, Shraddha. We are taking the difference. So we will need to...
Still, they will have the same parity, right? So if you're subtracting b from a, and or you're adding b from a, so you can either take a to be 5 and b to be 6, but then still you will get the same answer. So it's just the same parity as 66.
It's not very clear. Now, in the interest of time, what I will do is I will give you a simple way of doing it. You have 1, 2, 3, 4 up to 11. Okay. So you start with 6 even numbers and 5 odd numbers. Okay. Yeah. Now, we could do one of these, right? We could take 2 odd numbers. If we take 2 odd numbers, what happens? Like if we take 2 odd numbers, what are we going to do? We take away 2 odd numbers and write their difference, right? So if we take away 2 odd numbers, the difference is going to be even. So if we do this, the number of odds, let us look at how the number of odd numbers changes. If we were to take 2 odd numbers, our odd numbers will become +1 and no, odd numbers will become -2 and even numbers will become +1. Even number will increase by 1 because we are removing 2 odd numbers and we are adding 1 even number. If we take 2 even numbers, what will happen? Even numbers, we are taking away 2, but the difference is also an even number. Therefore, the even numbers will decrease by 1 and the odd numbers will remain 0. Will not change. Will not change. No change. Is this clear? If we take 2 even numbers disappear. Instead, we add 1 more, which means the total number of even numbers will reduce by 1, right? And if we take an odd number and an even number, 1 odd and 1 even, what happens is that the odd number reduces by 1, even number reduces by 1, But then what we are going to write will be odd, which means there will be no change for the odd number. It got reduced by 1, and odd number is no change, and even number reduces by 1. Right?
So basically, the odd numbers would be 3, and then the evens would be 5.
No. Odd numbers are decreasing by 2 or no change. Right?
So first the odd numbers would decrease by 2, and then it would become 3, and then no change, and then no change, so it would still be 3, and then evens plus 1 minus 1 is the same, then even after that we get even minus 1, which is 5. So 5 even, oh yeah.
We started with 6 odd numbers and 5 even numbers, right? We started with 6 odd numbers and 5 even numbers. That was a mistake that I wrote. 1 to 11, there are 6 odd numbers and 5 even numbers. And we see here that the odd numbers either does not change or decrease by 2, whereas the even numbers increase or decrease in steps of 1. The odd numbers can only decrease in steps of 2, right? So 6 from 6, can we eventually end up with 1 in somehow? We can only move in steps of 2 or remaining to 0. So we cannot end. If the last number that remains is odd, we will be left with 1 odd number, which is not possible. We always have to have an a even number of odd numbers. We started with 6 odd numbers, and odd numbers changes in steps of 2. So the number of odd numbers will always have to be even, and therefore we cannot end with an odd number. We always need to end with an even number.
A minus b has the same parity of a plus b, so why don't we just add them instead of doing all this? Why don't we just add all the numbers from 1 to 11 and find out its parity? Because a minus b, suppose you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 written there. So if we take 5 minus 6, it will have the same parity of 5 plus 6. So why don't we just add them instead?
Okay, we are changing the numbers, no? We started with 1, 2, 3, 4, etc. up to 11, right? Now I removed 7 and 4 and I put in a 3 there.
Mom, it's okay if you start with any 2 numbers.
We are starting with 11 numbers. We are not doing A minus B minus C minus D minus D.
But
A plus B and A minus B have the same parity, but A plus B plus C and A minus B minus C, do they have the same parity? If you do A minus B minus C is different from A minus B minus C. When you're doing subtraction, the order becomes important. So what works for 2 will not work for many numbers. Is that clear?
So we can't just add them like that.
We can't just add. But I think what Yagnika, she was right, who said that this thing 66, and at each step we are doing A plus B minus A minus B, and A plus B and A minus B have the same parity. So 66 we are starting from an even number, and at each step we end up subtracting an even number from 66, and therefore we will end up with an even number. This we can write as 66 minus A plus B, if you know brackets, minus A minus B. This is what it is. Now, because these two have the same parity, this bracket will always be even. So at each step, we are subtracting an even number from 66, and therefore you end up with a even number. That works. What Yagnika said, that works.
Okay.
But not like what you were saying. Is that clear to you?
Yes, ma'am.
Is Yagnika's method clear to everyone? Are you comfortable handling brackets like this?
Yes.
Those of you who are, we saw that a plus b and a minus b have the same parity. Therefore, a plus b minus of a minus b will always be even. If this is odd, this is also odd. It is odd minus odd or even minus even. So this thing will always be even. And at each step, we are taking 66 minus an even number. Therefore, it remains even. If I were to use the language of invariance, then what I would say is that the number of odd numbers always has to remain even. Sorry, odd. The number of odd numbers. We started with 6 odd numbers. That is even. So the number of odd numbers always has to be even. The parity and the number of even numbers will change. So here the invariant is parity of number of odd numbers. Is that clear? That is it. So the problems can get really complicated. There are a few more problems which I have in the worksheet. We did not get time to solve, but a different this thing of problems can be solved. If there is, do they have a group or something where I can give them this set of problems, Harish, where they can go and work or something?
So the answer is
I'm not
odd,
sure.
right?
Not sure. Okay.
The
Somebody said
answer
something.
is odd, right?
No, the answer will be even. We said the number of odd numbers always has to be even. So if the last number happens to be odd, then we have one odd number, right? That cannot be.
Ma'am, may I ask one thing?
Yes, yes, please.
Ma'am, I cannot understand whatever operations you did by 66.
66. Okay, let me share screen again. This is what
They have
another
they have a
class.
Google Classroom where you can share the.
Okay. So I saw Ganesh somewhere. I have Ganesh ID. Ganesh, are you there? I'll send it to Ganesh. Or I'll
Sure,
send in that info, whatever your thing. So who asked me? I'm going to write in whatever page I have. So where did I get that 66? 1 plus, okay, whenever I start writing in a new page, it gets into trouble. Let me see if I can, okay. So that 66 was 1 plus 2 plus etc. up to 11. Okay. Now in that 66, what am I doing? I'm taking out, so the sum of the numbers on the board is 66. Now I remove two numbers A and B. So the sum of the numbers becomes 66 minus A plus B. Then what am I doing? I am writing back the difference of A minus B, absolute value, whichever is larger, the positive value. Okay. So the sum of the numbers on the board is always 66 minus the sum of the two numbers I removed plus the difference, right? Now, this I am assuming that A is the larger of the two. So just to avoid that absolute value, so I can just put that bracket. Now I will write this as 66 minus of A plus B minus A minus B, if you are comfortable working with brackets. Now these two, this is the sum of the numbers which are remaining on the board. Now A plus B and A minus B always have the same parity, either both are odd or both are even. So their difference of either two odd numbers or two even numbers will always be even. So at the end of first step, what I am doing is the sum of the numbers remaining is 66 minus an even number, which is an even number. Now the next step, it will be this even number minus another even number, which will again be even. Now this even number minus another even number. Like that, it will, each step I am subtracting an even number. So the sum of the numbers that remains on the board will always be even. always be even. So if I am left with one number also, that has to be true. The sum of the numbers which are remaining on the board has to be even, and therefore that number has to be even. It cannot be odd. Is that clear now? Athar, you were the one who asked. Is that clear to you? Athar?
Yeah, ma'am.
It's clear. Okay. Any other questions, anyone? If we don't have
I
any
don't think
questions.
we'll have time to take further questions. They have another class.
Okay, so we can wind up. Thank you all.
Yes, ma'am. Nivedita will be doing a vote of thanks.
Okay. Thank you so much, ma'am, for taking the time out for this session here. I feel like the best part of the session was that we just didn't keep solving problems again and again. We linked all of the problems back to the concept of invariance. So more than the problems that we solved, we can all take back that anytime we see a problem and it looks really big, we can still think about finding something that stays constant and working our way up from there. And that gives us a sense of, oh, I can solve this. And yeah, that was really nice. Thank you.
That's what I wanted you all to take away from the session. Yeah. Okay. So
thank you.
Thank you,
ma'am.
Students, you have another session at 4:45. Please don't forget to log in that.